Welcome back and thanks for following the series. If you've been keeping up with everything, in this video we're going to take a little bit of a detour from what we've been doing. We're going to pick that up after this video. We're going to go back into the player attacking and setting up some more stuff for the enemies. But today's video is actually going to be about globals or auto load scripts. So we're going to be creating two of them. We're going to have one for our player and we're going to have one for our levels. So we're going to go into our project and project settings, and in our globals, this is where we're going to be setting these up. So after we create these, we add them in here, and then these are all loaded whenever the game is started. And so what that's going to do for us is it's going to give us a single source of truth. So for the player manager, we're going to have one reference to the player throughout the entire game, which gives us easy player access first and foremost, and will allow us to have persistent player data throughout our entire game. It'll also help with respawning, which we'll get into in a future video. And then for our level manager, it's going to make it easier to organize our level flows. We can state track with our level manager and provide a checkpoint system, or consistent scene management with transitions. So there's a lot of intro, so let's actually get into creating these. So the first thing I'm going to do is create a new folder. I'm going to do _globals, just so those pop up. This folder is always at the top, and we're going to do our player manager first. So we're going to create our player manager script. Let's open that up. We're actually not going to give this one a class name. It is going to be referenced by the autoload, which I'll show you in a few minutes. And our player manager is actually pretty simple. The first thing that we're going to do is we need first and foremost, a reference to our player. So we actually can find our player scene, click and drag it, hold control, and it creates a constant, which is actually what we want here. Then we create a variable for our player of type player. So inside of our ready function, we're going to do a couple things. First thing we're going to do is create an instance of our player. So it's going to be player dot instantiate. So we're instantiating our one player that we're going to be using throughout this game. We're going to do an await just to make sure that that everything's going to be loading properly. We're going to do a short pause. We're going to do get tree, create a timer. Only going to do for 0.3 seconds, and then on timeout, it can proceed. So that's all we actually have to do there. Okay, so after we have this set up, we're going to actually input this into our globals now. So we go and select this, and this is why I'm not giving it a class either, because it would just match the name here and they can't overlap. So this is our first global script, and we can refer to it by this name. So now we can go back to our player script, and what we're going to have to do here, which before we initialize our state machine, we can reference this player manager, get the player variable. We're going to set it to self, so we are going to be the player. Now we're going to have access to this player manager.player, and it's going to refer to our current instance of the player. So we are going to be able to do things in our attack states or in other areas where we can explicitly reference our player. I think where this is going to come most in handy right now is going to be getting our enemy to look in our direction. So let's go back to our RoboCop script. So here, this is our RoboCop. We are going to make a new function called set direction. Okay. What we can do here is if player manager dot player. So now we can access the player from within our RoboCop script, even though we don't have a reference to it inside of that script per se. So we're going to get the position of our player on the x-axis, and if it's greater than the position.x, which would be RoboCop's position, we're going to return direction equals 1. Elif player manager dot player dot position dot x is less than position dot player dot x. Direction equals -1. And so what this is going to do is now our enemy's sprite is going to be flipping based on the direction that we're looking. So inside, we're going to make a process method now. So this is happening all the time, right? So now we can do set direction. Cool. All right, I'm actually going to move this. I didn't realize I put this above the physics process. I just want to clean this up a little bit. This will be easier. Set direction. All right, so now if we play this, let's check this out. Okay. Well, that didn't work. And it's pretty obvious as to why I did not. We're going to do, we didn't actually flip our sprite. So it's going to be equals to the direction greater than 0. Okay. So now this will work. Pretty cool. Okay. This is going to come in handy, especially when we're going to be creating more, we're going to be building out more of our enemy script, so it can actually chase and begin attacking our player. And you know what? Just me kind of thinking on the fly here. I think I'm actually going to start working on additional states for our enemy, so we can actually make him run and chase our player. So we're going to need to make a new component. So in our components here, I'm going to clean this up actually a little bit. First, let's do hitbox, hurtbox, and now let's make detection. Okay, just clean this up. Inside of here, we are going to make a new scene, which is our detection component. We'll leave it as a 2D scene for right now. Let's actually make this, we're going to want this to be an area 2D. We want to know when our player is entering this detection area. So now when we add a script, we'll be inheriting from the area 2D. And give this a class name. I don't even know if this is necessary. I just kind of have a habit and think it looks nice. And we're going to be looking for 2 signals. I want a player entered signal and a player exited signal. So what I want to be doing is I want to know when the player enters this detection component, because when the player's in it, I want the enemy to follow him or chase that player. And when the player leaves, I want that enemy to stop. So we need to click on our area 2D and go into our node over here. Also, I should spell player correctly. And what we're going to be doing is checking in this area 2D if a body is entering. So when we double click here, this is automatically linking us to this signal here. Okay. So what we want to do in here, we're going to first check if the body is player. Because if it's not a player, I don't care, right? So then we're going to do player entered.emit, and we're also going to do body exited. Okay. Don't know what just happened there. Oh, all right, I lost my, all right, yeah, I don't know what's going on there. Weird. Okay, we're gonna do the same thing here. If body is player, player exited dot emit. Okay, now let's go into RoboCop. We're gonna give him a detection component. I'm actually going to, since we're gonna be adding components down the road, I'm gonna give him a node that can just hold all of our components. Okay, so now we can add collision shape 2D to our RoboCop. I'm going to make this a circle. I'm going to make it pretty big. And I'm going to make it orange. I don't know why. We're going to make it orange. Okay, so now I want to detect whenever this player is in here, right? Okay, so in order to make this work correctly, I think we're going to need to actually set up our enemy state machine. It's going to look very similar to our player state machine, but we have to configure it to be enemy specific. So let's go in and create our enemy state first. So I moved some things around where I put the state machine. I'm actually going to move these back. I don't like that. This is all player state stuff. So we don't have anything in components, but we are going to create a new folder in enemies called state. And we're going to add a new script, call it enemy state. And we're also going to create enemy state machine. Let's focus on the state first. So we're going to give this a class name of enemy state. It cannot be called state because that will clash with the player class names for state. And the first thing we're going to need here, this will look a little familiar, static var of enemy, and it's of enemy type. We actually don't have an enemy type, so we're just going to make this specific to RoboCop for right now. Okay, static var enemy state machine, and it's going to be of type enemy state machine, which we haven't created yet. We'll do that right now just so we get rid of that. Okay, let's go back to our enemy state, and this is going to look similar to our state. So I am just going to go back to our normal state, and we're going to copy all of these except for input. We're not going to be handling input with our enemies, so that's going to be kind of the one key difference. Get rid of some of these notes, okay? And one of the other differences is that we're not returning a state, we're returning an enemy state. So we need to make sure that's right, or else we'll be returning incorrect types. Now we're going to go into our enemy state machine, and this is also going to look pretty familiar. We need an array of our enemy state. Start off as an empty array. Current state is an enemy state. Previous state is an enemy state. And then our ready function, I'm actually going to go to our state machine and then copy these, go back to our enemy state machine, just copy that. Because the ready process and physics process are going to be the same here. And I believe we can also, let me look at our state script or state machine script. We should be able to take this as well. And we can actually take both of these. We can take both of these. Let's go back to our enemy state machine. Okay. So we're going to get a lot of errors here because this is not configured for enemies yet. So we want RoboCop of type RoboCop, right? That's what we are expecting here. In states, we're not looking for an enemy state, first of all. If there's not states, return, that's fine. This is going to be RoboCop, and it's going to equal RoboCop. The enemy state machine is going to equal self. Okay, we're expecting an enemy state. And we are still getting an error here. It says states is not declared. Oh. Jesus, getting ahead of myself. Okay. All right, now we're good. Now we need to go back to our enemy. We need to configure, well, RoboCop. We need to go back to RoboCop. We need to configure our state machine. In order to configure our state machine, we do have to add it as a node. So we're going to create enemy state machine. We're going to give it our script, and we're going to create two nodes. We're going to do an idle state and a run state. Okay. These are each going to get their own scripts. So idle state can be an enemy. I want to put it in state though. Idle state. Great. It's going to be class name enemy idle state again because it can't clash with our player idle state. We're going to make a state for this, or a script for this state as well, for run state. Jesus, I can't type today. Enemy run state. Okay. Great. Now we want to go back to our enemy state. Or sorry, we'll go make sure this is going to be configured correctly. So in here, we can drag our state machine, right? And now we can do enemy state machine dot configure self. Okay. So now our state machine is all set up. Now we can go back to our enemy state. Enemy state here. We're going to take all of these, put these in our idle state. We're also going to put these, while we have them copied, in our run state. Okay. We're going to need a reference to our idles or our run state, so that's good. And when we enter this one, we're going to do animation player. Sorry, we need to do robocop dot animation player dot play idle. We're going to make sure the robocop's velocity dot x is 0 because he's not moving. And then we need a reference to this detection component, so then we can connect to that signal. Player entered dot connect on player entered. Okay, we don't have that yet. Okay, yeah, we don't have that yet. So let's go back to our idle state. We're going to make this method. Okay. And what we're going to do here is we're going to disconnect from that signal, which is more or less the same thing. Player entered dot disconnect. Let me call ourself because we're disconnecting ourself. All right. Sorry, it needs a callable, not self. That's state machine, not this. Yeah, on player entered. And then we're going to do enemy state machine dot change state run state. So it's a little bit different, right? Like we're not returning the state here. Change state argument should be enemy state, but is enemy run state. Okay, so this is not an enemy state yet. Okay, that should fix that error. Great. And now let's do our run state. When we enter here, doing the enemy, keep calling him enemy, sorry, dot animation player dot play run. We're also going to do our detection component, which let's go back, it's idle and detection component. Detection component dot player exited. We want to connect to that one because we want to know when the player exit. We can call on player exit. Let's make this func on player exit, and it's going to look very similar to what we're doing in the idle one when we're connecting to on when the player enters. So we're going to do player exited. We're going to disconnect it on player exit. Great. And then we're going to change enemy state machine dot change state idle state. We haven't done anything to make our robocop move. So what we're going to do now is we're going to make a method called handle running. This is going to look pretty similar to our player. Let's actually see what we have in our player run state. Let's go to our run state. It's similar to that. It's not identical. So let's just go write this in handle running. It's going to do if robocop.direction. So if he has a direction, robocop.velocity.x is going to equal the robocop's direction times its speed. Okay? And if not, enemy, Jesus, robocop.velocity.x is going to equal move toward, which we've used before, velocity.x, 0, robocop speed. I also need robocop here. Okay. So now that we have all of this set up, we also are going to need to handle the running in our physics process. Okay. I'm actually going to underscore this. This shouldn't be used anywhere else. Okay. So let's see if we have this configured right. All right. He's entering. Okay. So we still have some stuff we need to set up. We've configured the enemy state machine. Let's see if we're actually entering a state. Let's put a breakpoint here. Let's enter. Okay. So we're getting states, which is an array of 2, which is good. We're going to go to, okay. So he is entering. He's just not moving. Do we set the player direction? We have set direction, or set the enemy direction. We have move and slide. We have the enemy state machine. Okay. Oh. We didn't ever give him a speed. Okay. That would make a lot of sense. We're just multiplying it all by 0. So let's remove that breakpoint and go in. All right, he's moving. I have no idea why this is up here, but everything else is intact. I want this to be moving with our player, or with our enemy. So let me go back to the RoboCop scene. I think this is just because this isn't following. I don't think I'm actually going to put it in this components. I think that's going to make this better. Okay, so now I changed its path. So that's why I'm getting those errors. Okay, I think we're probably going to get one more. No. Yes, detection component. We no longer have components. Let's rerun. Okay, there we go. And I move, he stops. I jump over him, he follows me until I'm out of reach. All right, pretty cool. We definitely want to build on this. This is not, we need to do player knockback. I want to add some animations for when, you know, our death animations. I want some sound effects. We need to add a little bit of game juice, I think is what they would call it. So we will look to do that in the next video.